How this relates to isolation? You mentioned the word isolation. Modules isolate code by having private scope, requiring explicit exports, requiring implicit imports. When you use import asterisk as stuff, you're preserving that isolation boundary visually. You're saying everything from that modules lives inside this namespace, which is stuff, no leaking. So that's what it means by requiring explicit imports. So it also at the same time allow us to have private scope unconsciously. Connect this to your bigger architectural learning. This is the module pattern enforced at language level. Instead of global variables floating everywhere, baker.bake function, you now require stuff.baker.bake. So instead of like using baker.bake that could be used by other modules in our directory because it's the same file name with the same method, like baker is the file name, that bake is the method, so they might be using that as well. In this case, you're avoiding the namespace global pollution, which makes dependencies explicit. That's decoupling, that's boundary clarity, that's scalable architecture. Number 6, important detail most people miss. The namespace object stuff is read-only, leave-bound, meaning if the original module updates a value, stop sees it, but you cannot reassign. Another way of looking at leave-bound is that it is only applicable when that module is instantiated. If it isn't, if it was deleted, you won't be able to use that. So stuff equal empty, open and close curly brackets, or stuff.baker equals something else. That's part of module safety. Why it feels confusing? Because the example suddenly switches styles from import open semi-curly bracket baker closing semi-curly bracket to import asterisk as stuff without explaining. It's just another import syntax. So unfortunately the book wasn't able to explain why it changes the import syntax. It's not introducing a new concept, it's just grouping exports into an object. So we just group that export into an object in this one line import at the top. So simple mental model, think of it like this. Name import, give me just the tools I need. Namespace import, give me the wool toolbox. Both are valid. Why this matters for React later? React code often does this, import asterisk as React from code React semicolon instead of import open semi-curly bracket use date comma use effect closing semi-curly bracket from code React closing semicolon. Same idea. Namespace versus named import. Final clarification, nothing magical happened. Stuff is just a variable name. You could write import asterisk as kitchen stuff from code./stuff.mjs closing semicolon. So another important concept is that the stuff is a variable and an object at the same time. So it is just used to explicitly export all of the methods on that file and rename it to avoid global name pollution. It would work the same. The name after as is arbitrary. It's just a namespace object holding all exported members. Module loaded from remote resources. ES 2015 Plus also support remote modules, i.e. third-party libraries, making it simplistic to load modules from external locations. Here's an example of pulling in the module we defined previously and utilizing it. Import open semi-curly bracket cake factory closing curly bracket from code https example.com/module/cakefactory.mjs semicolon. So this eagerly loaded static import. So basically, when we say eagerly loaded static import, is that we load the dependencies of that module before we even use that module. Unlike with dynamic import, we wait for that specific method to be used on our app before we load it from that third-party sources. So here, cakefactory.open.make cupcake argument sprinkles closing. The next line, cakefactory.oven.make muffin argument large semicolon. Static imports. The type of import just discussed here is called static import. The module graph needs to be downloaded and executed with static import before the main code can run. This can sometimes lead to eager loading of a lot of code up front on the initial page load, which can be expensive and delay key features being available earlier. So basically, the one we discussed, um, requires the module graph to download and execute those dependencies before it can even be used. So this sometimes can lead to eager loading of a lot of code upfront on the initial page load, which can be expensive and delay key features being available earlier. So another thing is that it's like a server side rendering in which you loaded everything before you even show it, and a client side rendering similar to static import. So here are the previous example. So basically we're just explaining the advantage and disadvantage of this kind of import. So what static import actually means: when you write import cakefactory from /module/cakefactory.mjs semicolon, this import is at the top level, not inside a function, not conditional, not dynamic. Because of that, the browser can detect it before running the file. So because it's at the top and not inside the function, not conditional, not dynamic, the browser will be able to see it before the code at the bottom, because that's just how the browser read it, from top to bottom. So before your main.js runs, the browser first download your main file, second sees the import, so it download that main file first. You may think that it's the first one the browser download, but no, it's actually the whole file. And then it's just scan through line by line from top to bottom, and it will seize the import download /module/cakefactory.mjs. If that file imports other modules, it downloads those too. FIP builds a dependency graph. So you can think of it as the dependency acyclic graph we discussed in Redux. 6 executes everything in order from top to bottom, as well with that the dependency it also executes that code from top to bottom, just like this main module. 7 then runs your main code. That whole dependency tree is the module graph. So that's what we are saying, that as a module graph that needs to be downloaded and executed here. So this wool dependency tree, or this sequence of step, is actually what the module graph is. This is called static because the structure of imports is known at parse time. It doesn't change at runtime. So it was changed or known at compile time compared to dynamic import, which is known at runtime. Why do you say eager loading? Because static imports are loaded immediately when the page loads. Even if cakefactory.oven.make cupcake argument code sprinkles closing runs only after a button click later. The module was already downloaded at page start. That's eager loading. What would be different? The alternate is dynamic import, such as const module equal await import code slash module slash cakefactory.mjs closing. This only downloads when that line executes. That's lazy loading. So what's confusing you? It feels like this looks exactly like the normal import I've been using, because it is. The term static import is just the formal name for the normal import syntax. They're not introducing something new. They're classifying what you already know. That's why it feels like poor wording. The real difference, mental model, static import, known before execution, always loaded at start, part of module graph. Dynamic import, known only when executed, loaded later, returns a promise. That's it. So another key difference is that with dynamic import, since with the lazy loading, another way of thinking is with the lazy loading, it returns a promise that it will execute this once you click it, but it's not immediate because it needs to be concurrent with other methods on your app. So now here's the deeper system insight. So think about that promise, kind of like returning an asynchronous code or execution with TypeScript backend or Node.js. Now here's the deeper system insight. This is where your OS plus networking knowledge connect. Static import affects initial page load time, network waterfall, bundle splitting, code splitting strategies in React. This is why tools like Webpack and Vite analyze static imports. They need to build the dependency graph ahead of time. Dynamic imports create separate chunks. That's architecture level impact. So the way the module graph of static import of a built-in JavaScript works is actually taking advantage of Webpack and Vite on how they analyze static imports before they actually render the content to the user. So Vite also load all of that, or they use like this dependency graph to be able to return the methods immediately. That's why you see like an immediate response from Byte, because they downloaded all the dependencies. Contrast that with the dynamic import, in which it returns just a promise because it only loads the required method upon need of an action. So the reason this feels confusing is because you're expecting new behavior, but they're just labeling something you've been using. That's not your fault. That's documentation language assuming background context. So let me test your understanding. If I put this inside the click handler button that add event listener argument click comma async pointing to const module equal await import argument slash module slash cakefactory.mjs, then closing, when does the browser download the module? If you can answer that confidently, you fully understand static versus dynamic. So this module certainly downloaded dynamically because it didn't import it at the first line of the module. And notice something, this confusion is not about React, it's about execution timing, or the semantics of the language, or the basics of JavaScript. Dynamic imports. Sometimes you don't want to load a module upfront, but on demand when needed. Lazy loading modules allow you to load what you need when needed. For example, when the user clicks a link or a button. This improves the initial load time performance. Dynamic import was introduced to make this possible. So again, just like with client rendering, in which you don't load it or you don't render it everything at once, it makes the initial loading because you're essentially just providing the X-ray or just the template of the whole module. Or in the case of rendering, is that you're just providing the template of the whole app. You're not rendering, or you're just lazy loading all the needed methods as the user needs it. So the dynamic import introduces a new function like form of import. So import URL, argument URL returns a promise for the module namespace, object of the requested module, which is created after fetching, instantiating, and evaluating all of the module's dependencies as well as the module itself. Here's an example that shows dynamic imports for the Cake Factory module. Let's just continue with this.